Hello, Assalamu alaikum. My name is Manali and welcome back. In our lecture 2, we study gates and multiplexers and we study the behavior of gates, AND gate, NAND gate, how they work, OR gate, use them in the circuits, NOR gate and XOR gate, all gates we use in that circuits. And also we study the multiplexer and how the multiplexer works in the our circuits and how the behavior of multiplexer. Now we come to our circuit. We type and today I show you how the logging into the multi circuit works. Go to the sign up. Here you type your name, small Ali, email address, small Ali3, and enter your password and click on I'm not a robot and it's check up. Click on the sign up button. Here you will say you here and click on the launch simulator. You see here your account is logged in here and your name is showing here. Now you save your circuit online and use them after when you need them. Now we can replace everything right. Here you see a button here. We use it again. Put it here. Properties. Now we come to our circuit. We use all the gates, AND gates, OR gates, NOT gate, all the gates we use in our today video. First choose an input, place it here, choose another input and place it here. Here is a button you see here. You zoom in and zoom out with that. Also you press your plus key on your keyboard to zoom in and zoom out. Now take a gate. First we take AND gate, place it here and then connect the terminals. When you're using it, make sure the point is connecting on the right place. You see it is not on the right place. Therefore, little zoom in, then connect the point on the right place. Now take an output here, connect the output. The behavior of AND gate is when the input is 0, 0 is showing a 0. When the input 1 is 1, then showing 0, and input both inputs are 1, then show 1. First we label them, click on the input 1. Here in goes in properties, and there is a point label, and type here label A. Here is the direction where you want to uh, place the label on the right point, down, left, and up. We need it on the left direction, therefore press left, and also we label input 2 and B. Now we label output as a output, output. That's nice. You see it here. Now it's point A and B and output. We also label AND gate here in the direction AND gate and place it up. Here you see it. It is our first gate AND gate and we see it works. 0, 0 is showing 0, 1, 0 is showing 0, 0, 1 is showing 0, and when the both inputs are 1, it's showing 1. It means it's showing the correct value. Here is a thing which use a flag here. Place it here. I show you what is timing diagram. It show the output it's 0 or 1 when we connect the flag on our output line. Here is our output line and connect the flag here. Here you see it is flag. We label our flag here. Flag. You see it here. Now here you see it is the timing diagram. When you place it here and double click on it, it's showing a timing diagram little bit increase. Place it here. You see it's showing upward, going up line. When if any input is become 0, it's showing here it's go. Here is our timing diagram. Flag stop and resume here. It's showing now showing its lower line. It means the output is 0. When we increase to our both the inputs are high, then it's showing up. Here you see here is a change when the both inputs are high. It is our timing diagram of the AND gate. So we stop it from pausing timing arm and minimize it. Now we delete our first input AND gate. A little bit stop it. And how we increase the bandwidth of input. We click on the input, go to properties, and here you see it is the bandwidth. We want to increase the bandwidth of our input, then we input 4 or 2. Here the bandwidth is increases and it show you here it is the bandwidth is giving some error. Bandwidth error 2 into 1 because one input is 2 and other is 1 and output is 1 is showing the output error. We have to all the bandwidth is equal to 2 here. Sorry, here you see now it's showing the correct result. When the one input is 1, other is 0 and 1 1 is showing 1 0. It's correct result. Both input is 1. We have to also increase the bandwidth of AND gate. Click on the AND gate. Here you see the bandwidth of the AND gate and we place it also too. Now it's showing the correct result. First, we place all the zeros, then increase 1. Here you see there is no change. Then we increase another one here. You see there is no change. When increase 1 here, it show 1 0. And here is both are 1. They are showing 1 here and 1 comes 1 0 is showing 0 because it is AND gate. And we see our timing diagram here. We resume it. It's showing here. It's because it's showing 1 here for where you see it here. We have to increase the bandwidth of our sphere and put it 2 because we need 2 lines of the bandwidth. We place it down. Here is the point which we increase our lines. It's showing both the lines are changed. You see it here. The both lines are on the up direction. You see with our diagram. Now we also decrease our bandwidth of all the things to 1 because we just want to study the bandwidth. Just 1, delete 1, and we also delete and point it 1. Now it's okay. Now we study our next gate, which is a OR gate. Point it here, connect the lines, and connect to the output. When the input 1 is 1, the output show 1 because it is AND OR gate. And both outputs are 1, it's showing 1. When the both inputs are 0, it's showing output 0. And we also see in this in the diagram when the one input is 1, it's showing 1 A input and B input is 1, it's not going. When the both inputs are 0, it's showing 0. You see it here. We study our next gate, which is NOT gate. NOT gate is a single line gate which we choose it. We don't need our second input B. because it is a NOT gate which it's only one input. We connect it here. When it's zero, it's showing one because the work of NOT gate it inverts the input and change the value. When it is one, it's showing zero, and when it is zero, it's showing one. We also see the its timing diagram. When it's zero, it's showing one upper line. When it's one, it's showing the lower line. Here you see it. Now we minimize it and delete our NOT gate, point it our back here, and XOR gate, bring it here, the bit. See it's not on the right point, point it here. Now we connect the non-pair gate. The work of XOR gate is that it's when the input one A and B is different, it's showing one. You see it here, it's showing one, showing one. When the inputs A and B are same, it's showing zero. You see it here, it's showing zero. You also see it in time diagram one is showing one when the different is showing high input, high output on the upper line. You see it here. When it's showing same input, it's showing the zero. You see it here. It is our XOR gate. We delete our XOR gate. It is there. We are showing. Want to show you the truth table of the all the gates. Here is the NAND gate, which is opposite of the AND gate, and showing the just opposite result of the AND gate. When the both inputs are zero, it's showing one. Out just opposite of the AND gate. You see it here. We're changing the value. And NOR gate is also just opposite of the OR gate. You see it here. It's just opposite of the OR gate because this bubble invert the output. XOR gate is also just opposite of the XOR gate. And X NOR gate is just opposite of the XOR gate because this bubble you see it here. I point it here and zoom in. This bubble you see it here. It just opposite the input. When the input is high, it shows the low output. When the input is low, it shows the high output. You see just as not yet, mark of the not yet. Just delete it and zoom out. Here is our all the gates we use in our circuits. Just Control plus A to select all things and backspace to delete everything. Now we use multiplexer here. Now we want to know how the multiplexer works. We input one point, another point, and here is another point which is low, and point the output. Just now you see, connect the output, connect the inputs. Here you want to point the point here. You want to point the upper direction. Just press the up key, click the input, press the up key. It should show it's up on the direction. You also through your rotation up and down where you want the direction. I want to its up direction, you point it up. Now connect it. Now you see I zoom in and show you point it. Here is the first input A and the second input B, and here is our multiplexer, and here is the point you see on the screen is showing the control signal. It means when we need A input, we point it 0 because you see it here is a 0. When we point it 0, it's given output of the A. So it goes to here, to process here, and go the output. When we point it 1, it show the 0 point here. You see 1. It's go here, process it, and control signal select the 1 and it's go to here in the output direction. Here is the work of the multiplexer which we use in our circuits for processor. How we increase the signals of the multiplexer. Just disconnect it, delete, click on the multiplexer. Here you want to increase the bandwidth, you increase it here, and you want to increase the points, that points. Just go to here, delete, point it to. Now you see it here. Now it's on the 4 points because it is take the formula 2 and 2. You see it here, point it here, and it increase the input. We need more inputs to work with multiplexer. If we do not need any input on the point 3, we just not connect any input to it because we don't need it. We just connect it here or here and connect it here. We just replace, we don't need our input 3, we replace it here. And now we connect our select signal here. Now you see it's giving some error here. You see it here, bandwidth error 1 and 2, because the we select signal is 1, which can't control the 4 inputs. We need here the 4 bandwidth of the 2 input because we need the control the 4 signal here. We control it here 1, 0, 0 with pointing at that point, then 0, 1 with pointing that point, then 1, 0 with pointing that point, and then 1, 1 which pointing that point, and giving the input to the output. And it's selecting the input where which want to go to output. It is the way how the multiplexer works. Just control all and backspace. We just study the multiplexer. Now we click on the decoder here. Decoder device is to decode the input which we want to input here. Here, input. We connect an output here. Here you see the input is 0 is showing decoded to 2 points, where 0 0 is showing 1 0. We increase the bandwidth here, point it to value F. You see it's now giving some error here because 2 input not showing on the single points. Therefore, we also have to decrease our inputs here. You see it here 0 is showing 1 0, which is point at 0 point here. You see, and 1 is showing 1 point. It is just opposite to the multiplexer. Multiplexers first take input, then it point to the output, and decoder first take the one input and point it to the other output, two outputs. It's just different as multiplexer. Just I showed you here. You see it's pointed two inputs here. Sorry, just point it here, here, and pointed output. Here you see our multiplexer and input here, subtraction here. You see multiplexer taking two inputs and giving one output, and decoder taking one input and giving two outputs. They are just different from one and each other. Control plus A and delete. Now we make some gates and I show you how to save the circuits. Just take just AND gates, main gates, OR gate, NOT gate, and XOR gate to show you the outputs. I connect all the input points on the same direction. You see it here. A point and connect the B points to the same points of the. I replace little bit, delete the AND gate because I don't need it here from the instance. Put it here, delete here and here. You see, delete, delete, and zoom out, and I'll show you how to save the circuit. Point 1 input here, point 2 input, and 3 outputs. Every output connect to the same point. You want to select some points, you have to click the shift and double click, and it show you here, it's showing selecting some image. Then place it and click. It is a way how to select the some points. Now you see it's our circuit. I connect all the points here, input A points. You see it here and connect it to the A point, label it here A, label it B, and and gate, gate, and point it. I just point it and up and label it up direction, or gate, orientation up, and or and XOR, label it. Now our circuit is just here. We point it here. You see it. It's showing the different point. We study all it. Now we want to save our circuit. We just pull our that slide here. You see it's here. Save online and select save offline. Here is our circuit. We want to change our project name. We project name it to gates here. We are studying gates and main we choose here. See main we decrease and point it one circuit one. Point it here. Click enter. Then we want to save online. Click on the save online. Now you see it here is processing. Now you see it a new window is pop up. Now you see our project name is gates. You see it here and public. Here is the project access type. If you want to you everyone sees your project, you point it public here, and you want to just you see your project, and you have to point it private. And if you want to access something, limited access, some people you want to when they have link of your code, you want to share them, they only see they see your project. I place is public here in update project. You see it here. Here is our project simulator. There is some problem. Let's see, and then oh, there is some inputs error. Just connect it here. Connect another here. When I'm saving, it just delete some input, or there is in connection problem. When there is a problem in the connection, which decrease some input to connect it, and connect it. Then Control plus S. Now we just save it again. We make save project. It did not show another window. Now click on the circuit first here. Here you click on your name here, small, and dashboard, which here you all circuits are. Click on your dashboard. Here you see your project is here, saved online. When you want to launch or use your project, just click on launch or more options here if you want to use your project again. And that is for our that video. We study gates, properties of the gates, we study multiplexers, and we also study decoder, and multiplexer, and we study is like the flag, how the our signals work, the flag signals work, the timing diagrams. Here you see our timing diagram. We study the timing diagrams, and here you see our first lab. And thank you for lecture 2, and good luck for next lecture.